We're going to look at an important result on improper integrals in this video. So the question is, let p be a positive number, and we want to know for what values of p will the integral from 0 to 1 of 1 divided by x to the p converge. And after we answer that question, we want to know for what values of p will that integral from 0 to 1 over x to the p, diverge. So first we'll consider the case p equals 1. That means 1 over x to the p is 1 over x. We already did this case in an earlier video, but I'm just going to go ahead and repeat this here. The integral from 0 to 1 over x dx, can be expressed as the limit as t approaches 0 from the right of integrals from t to 1 of 1 over x dx. And the reason for that is we look at the interval from 0 to 1. The function 1 over x is undefined at 0, but if t is any number strictly between 0 and 1 over x is defined at t, and so if we let t approach 0 from the right, we'll be able to obtain the value of the improper integral 0 to 1 over x dx if it exists, and if the limit doesn't exist, the integral will diverge. So we can express the integral 0 to 1 over x dx as the limit as t approaches 0 from the right of the integral from t to 1 of 1 over x dx, and that's the limit as t approaches 0 from the right of natural log of x evaluated from t to 1. And let's plug in both 1 and t for x. This is the limit t approaches 0 from the right of natural log of 1 minus natural log of t. And natural log of 1 is 0, so this is negative limit t approaches 0 from the right of natural log of t. That limit is negative infinity, and then the minus in front gives us something like minus a minus infinity, which is infinity. That means the integral, improper integral from 0 to 1 of 1 over x dx diverges. And so the integral 0 to 1 over x to the p diverges for the case where p is 1. Now we want to examine the other possibilities. So the next case we're going to examine is if p is strictly greater than 0 and less than 1. So like 1/2, 1/8, 7 over 15. Again, the integral is improper because 1 over x to the p is undefined at 0. So we use the limit to define it. Limit t approaches 0 from the right of integral from t to 1 of x to the negative p dx, which is the limit as t approaches 0 from the right of x to the negative p plus 1 divided by negative p plus 1, and that's evaluated from t to 1. Let's factor out the constant 1 minus p to the front of the limit, and so it would be 1 over 1 minus p times the limit t approaches 0 from the right of x to the 1 minus p evaluated from t to 1. 1 divided by 1 minus p times limit t approaches 0 from the right of 1 minus t to the 1 minus p power. And this is equal to 1 divided by 1 minus p times 1, which is 1 divided by 1 minus p, because since p is below 1, 1 minus p is positive. And that means that t to the 1 minus p is t raised to a positive power. That means the limit as t approaches 0 from the right of t to the 1 minus p is going to be 0. And so the conclusion is the improper integral from 0 to 1 of 1 over x to the p dx converges. And we know exactly what it converges to, 1 divided by 1 minus p. And that's true for p strictly below 1 and strictly above 0. And now we want to look at the last case where p is greater than 1. So in this case, again, we do the same thing. We repeat what we did before. We define the improper integral as the limit of t approaching 0 from the right of integral from t to 1 x to the negative p dx. So this is the limit t approaches 0 from the right of now x to the negative p plus 1 over negative p plus 1, evaluated from t to 1. Let's factor that constant out, 1 divided by 1 minus p to the front of the limit, and then times limit t approaches 0 from the right of, if we plug in 1, well, let's write x to the negative p plus 1 as 1 over x to the p minus 1, and that's evaluated from t to 1. So 1 divided by 1 minus p times limit t approaches 0 from the right. Now let's plug in 1 for x and t for x, so we get 1 minus 1 divided by t to the p minus 1. So we want to see what this limit equals to. So this is 1 divided by 1 minus p times 1 minus, and then we have minus infinity, because since p is greater than 1, so it's a negative number times negative infinity, which is infinity. This is because since p is greater than 1, it means 1 minus p is negative, and so 1 divided by 1 minus p is negative. That constant in front of the limit is negative, and p minus 1 is positive, so that the limit t approaches 0 from the right of 1 divided by t to the p minus 1 is 1 over a small positive number, which means it's going to positive infinity. Hence, the integral from 0 to 1 of 1 divided by x to the p dx diverges for p greater than 1. So now we want to summarize what we did over the last couple of videos. For p equals to 1, integral 0 to 1, 1 over x dx diverges. And so does, again, shown in an earlier video, so does the integral from 1 to infinity of 1 over x dx. So both of these integrals diverge, and we can use the picture to show what that means. So if you look at quadrant number 1, there's a graph of y equals to f of x equals to 1 over x. And if we split it up, right here, the area from 1 to infinity under this curve is infinite. And the area from 0 to 1 under this curve is also infinite. Okay, then let's look at the case where p is strictly greater than 0 and less than 1. We know that the integral from 0 to 1, 1 over x to the p dx, converges. And we know that it converges to 1 divided by 1 minus p. And we also know, we saw in an earlier video, that the integral from 1 to infinity, 1 over x to the p dx, diverges. So again, we want to use the graph to show this phenomena. Again, here's the graph. Y equals f of x equals 1 over x to the p. Remember, p is between 0 and 1. We'll split it up. The integral, the area below this curve from 1 to infinity is infinite. But the area below this curve over the interval 0 to 1 is finite, and it equals to 1 divided by 1 minus p. And now let's look at the last case. The last case is p greater than 1. So we know the integral from 0 to 1, 1 over x to the p dx, diverges. We showed that earlier in this video. And the integral from 1 to infinity, 1 over x to the p dx, converges. And it converges to 1 divided by p minus 1. So again, looking at the graph, all the graphs look sort of similar, no matter what p is. So here's the graph of 1 divided by x to the pth power. And if we split up this area from 1 to infinity, that area is finite. And we know it's, not only do we know that it is finite, we know that it equals to 1 divided by p minus 1. And then the area from 0 to 1 below this curve is infinite.